right, sixth graders, today we start algebra! Woohoo! All right, we have made it to chapter 5. All right, chapter 5, algebra. So, first of all, we want to know what is algebra and what are algebraic expressions. Well, by the end of today, you will be able to tell us what an algebraic expression is. You will also be able to tell us what terms are, the different parts of an algebraic expression, and you will also be able to evaluate an algebraic expression by the end of 5.1, which we'll finish out tomorrow. So pretty soon you will be solving algebra problems. That's right, problems with both numbers and letters. Craziness! So excited. All right, but first we need to know what is an algebraic expression and how do I identify the different parts of an algebraic expression? Well, let's talk about what that is. So, algebraic expressions are math sentences. But they're not just any old math sentences, they are algebra sentences. That means that they are math sentences that have numbers, letters, which we call variables, and operations. So our first vocabulary term is, can't spell, algebraic expression. Okay, an algebraic expression is a fancy word for a math sentence with numbers. So this is just a fancy word for a math sentence with numbers, symbols, operations, so operations, and variables, which are just letters. So algebraic expressions have numbers, operations, and variables. All right, so I'm going to make sure I move my math book here so I make sure to give you all the good stuff and not miss anything in our notes, anything noteworthy. Alrighty, so it's going to be, I'm going to color code a lot of stuff today so that we can identify different things. So first of all, when we have an algebraic expression would look something like this. I'm going to show it to you, but I'm going to color code each part as I'm writing it. Okay, so you would have many different parts here. So you would have a 5 stuck to a letter, like the letter P, for example. You would have an operation like a plus sign, and you would have something like just some regular old number, like a 4. Okay, this right here is an example of an algebraic expression. So now we're going to break this algebraic expression into different parts. Okay, so an algebraic expression has what we call terms. Okay, so the terms are like a shopping list of the things you need in order to make this algebraic expression. So if I were to make an algebraic expression that looked like this, I would need a 5p and I would need a 4 I would also need a plus sign. That's how I would make this algebraic expression. The terms, though, are just 5p and 4. So the terms are the different parts that make up the expression. So we're going to write down the word terms. So that's our next word that I want you to write down. The word is terms. So the word is terms. Okay, so terms are, like I just said, they are the parts that make up the algebraic expression or the math sentence. Now, if you don't have the terms, if you don't have those parts, you don't have the ingredients to make that math sentence. Okay, so terms are the parts or the pieces. Okay, without them, you don't have that math expression. So let's talk a little bit more about the word terms and break this down a little bit more, because each of these terms is called something. Okay, so let's first rewrite this, but we're going to write it a little bit bigger because we're going to be identifying the different pieces here. So again, I'm going to color code this into the same colors I had before. So I'm writing 5, and my 5 is still stuck to the P. I have a plus sign, and I have a 4. All right, so I have a 5p plus a 4. Now, these are the terms. 5p is a term, 4 is a term. So when we go to identify these later on, we will be able to understand that. Okay, the first part of the term that we have is a coefficient. So this red 5 is a coefficient. All right, so a coefficient is a number stuck to a letter. So it's the number that is stuck to the letter. It's not able to stand alone. It needs a partner in crime, okay? So think about like a co-pilot, okay? A co-pilot can't do its job unless it has a regular pilot with it, okay? A co-worker. Workers can't do their job unless they have a co-worker with them. They're not able to stand alone. You have a co-worker. A co-captain. So like a co-captain is a person who is like on a ship, right? So a person can't move a ship, sail a ship, drive a ship. What do you do with a ship? I don't know. So they can't make the ship go if they don't have a helper person, right? They're not able to do their job without somebody else helping them do it, okay? So a coefficient is a number that isn't really a number. This 5 is not really a 5. It's an imposter. It's going to be a 5 if this P is a 1. That's the only time that this 5 will ever be a 5. Because this P is going to boss it around and tell it what to do. So a coefficient is a number stuck to a letter. It cannot stand alone. Okay, so it does not have any value unless P has value, all right? So coefficient. It's dependent on something else. All right, now let's talk about that P right there. That P is kind of bossy, okay? That P is a variable. It's a mystery, right? It's unknown. We don't know what this P really is. So we call this a variable because just like in science, how variables are able to change, this variable can also change. So it's like a placeholder, okay? So this variable is a symbol that holds the place for a number that it's going to change to. So this could be a 6. This could say 5 times 6. P could stand for 6. It could stand for 7. It could stand for 800. We don't know. Okay? This could mean $5 per peach. We don't know how many peaches were sold. So we use a placeholder until we find out how many peaches were actually sold. So this variable is a placeholder. It doesn't have a value until we give it a value. Okay, so it's a letter that I can make it say changes to a number. Okay, it is a placeholder. It holds the unknown into the unknown, right? Okay, so this is Elsa. No, just kidding. It's not. It's just a variable. It's a placeholder. All right. This plus sign is an operation, not like a medical operation like a doctor, but this is an operation. An operation are things like symbols, right? So these are symbols that tell us whether or not we are going to add, subtract, multiply, or divide. Okay, so they tell us to add, subtract. I'm going to start using this little dot now. So not only does algebra make you use letters for numbers, but now we're also switching to a dot for multiplication, because if you use a multiplication sign as the X, we might be thinking that you mean a letter. So you have to start using this little dot, or you can use parentheses, your choice, and division. Okay, so there's symbols. And last but not least, in our list of terms, we have this fancy little 4 out here. It's just hanging out all by itself because it is called a constant. It is called a constant because it is constantly a 4. It never changes. It's a number without a variable. See, this one has a variable. This one does not have a variable. This one is constantly a 4. When I look at this, I know I'm getting a 4. When I look at this, I'm like, what? What the heck am I getting here? This, when I look at this, I'm like, oh, I'm getting a 4. I'm not getting into some crazy business over here. Look at all that drama. Nope, just a regular, plain old 4. This one can stand alone. This one doesn't need anything to help it. It says it's a 4. It's going to stand alone, and it is going to be a 4. So a constant is a number without a variable. Okay? It means what it says it is. So if I say 4, you know 1, 2, 3, 4. I have 4. If I say give me 5, if I say add 5, you know to add 1, 2, 3, 4, 5. You know what 5 looks like. It's none of this business over here, right? So constant means it's constantly, you can depend on it. It's like one of those friends, that you have that when you need it to be what it's supposed to be, or they're always there for you, they never change. It's one of those people, okay? But it's a number. They're dependable. They're not going to change for anyone or anything. It's constant. Yeah, it's like that friend that you have. Okay, so that is a constant. Okay, so what do we do with all of this information? Well, really great question. We're going to use all of this information now to sort the parts of an algebraic expression. So they will say, you will see something that looks like this. You will have a problem and it'll look something like 5x plus 13. Okay, and they want to know what are the terms in this expression. Well, you can look at this problem here, problem example A. I'm going to draw a line here because we're going to have problem example B here pretty soon. I'm going to draw my really crooked, crazy line. So sorry about that. And we're going to start by looking at the word terms. Okay, well, I'm going to use this pink color because we didn't use this color yet. So, terms. All right, so let's look at the terms. When I look at this, in order to make this algebra sentence, if I were to bake this, I would need the ingredients of a 5x, and I would also need a 13. So I'm just replacing this plus sign with a, what is this thing called? A comma, okay? So I'm just replacing my symbol, my operation, with a comma. I now have a list. This is my shopping list. To make this, I need a 5x and I need a 13. That's it. Okay, now I want to know. So in order to make this, I needed a 5x and I needed a 13. But wait, there's more, okay? Which one of these is the coefficient? Is there a coefficient? Do we have coefficients here? Yes. So the terms are the list. The coefficient is the type of variable or the type of term. So the type of term that we have, not a type of variable, I misspoke. The type of term that we have there, it's stuck to a variable. It is the number 5. So the coefficient that we have there is the number 5. It cannot stand alone. It has to be stuck to a number. Okay? Now, what about variables? Do we have any variables here? Do we have any variables to identify? Yes, we do. We have 1x, right? So we have an x in this problem. And last, but definitely not least, the word constant. So we want to identify constants. Constant. Do we have any constants to identify here? Yes, we do. The constant that we have to identify is a 13 because it is constantly a 13. I know what I'm getting into there. All right, let's do another example. All right, our next example that we're going to look at is example B. And then I'm going to draw a line here because I'm going to give you a try it to do over here, okay? So example B. Example B says 2z squared, that's a crazy one, plus y plus 3. 2z squared plus y plus 3. Okay, first of all, I want to know the terms. What am I shopping for? If I need to bake this thing up, what ingredients do I need? Well, I need the terms of 2z squared. I need a 2z squared. I need a y, and I need, a comma, and I need a 3. That is what I need to make this recipe. Those are my terms. Now, the types of terms that I need, so again, these are just types of terms. Okay, so the types of terms that I need, coefficients. Do I have any coefficients here? Any numbers stuck to letters? Numbers stuck to letters. Okay, well, I see right here, I have a 2 stuck to a z. So I'm just going to write down the 2. There is one that is really tricky, okay? The other one I have is right here. It's invisible. The reason why it's invisible is because it's a 1y. This is a 1y. They don't write 1y because a y is just a y. It is 1y. So when you write 1y, it's like you've already written 1y when you just write 1 or just write y. So a 1y. So the other one would be a 1. That's a tricky one. Don't get tricked by that. Okay, so make sure you have that in your notes. Okay, any other coefficients? Numbers stuck to letters. I don't see any either. Okay, letters. Let's look at our variables. What variables do we have? Well, I see a z and I see a y. And it's squared, right? It's a z squared. So I'm going to put z squared because that means I have 2 z's. It's a z squared and it's a z squared. I mean, it's a z and a z. We don't know what z is, so we can't tell what it is. So that's like saying I have 2 z's right there. So I'm going to write z squared, and I'm going to write the y. So you have z squared. Let me put the box around the squared so you see it. And I have the y. And last but not least, the constant. My constant in this is the 3. The 3 is a 3. We can see it. We know we can depend on it to always be a 3. Okay, it is your turn to do a try it. The try it that I have for you right now is 12 plus, this is your try it, 12 plus 10c. I want you to find me the terms, the coefficients, the variables, and the constants. Find all the different parts and hit pause so you don't hear me solving this for you. Otherwise, you're going to be really disappointed that you didn't get to do it on your own. All right, in order to solve this problem, hit pause. You need a 12 and a 10c. Those are my terms. That's the shopping list. The coefficient that I see is right here. It is the 10. It is the number stuck to a letter. It's right there. My variable is a c. And I have only one constant this time around. It is a 12. It will always be a 12. All right. In your own words, well, how did you do on that? How'd you do? Check your work. And then down below, I want you to answer the question, what are algebraic expressions? And how do we know we have all the parts of an algebraic expression? So go ahead down below, answer your essential question, and then put your rating in a box. How are you feeling about all of these vocabulary words? 1, Miss Englander, you are speaking some really weird foreign language right now. I have no clue what all these words mean, and I'm definitely going to be writing these down so I can use them. A 2. Okay, I'm starting to get the hang of this sorting business, but it is a little bit crazy and I definitely need more practice. Or 3. I feel okay with this. Algebra is really my style. I think I got this so far. Throw something harder at me. Okay, if you have any questions, head on over to the Google Classroom and ask me. Otherwise, make it a great day the Cougar way.